Hello there, welcome to another episode of Science and Technology Q&A for kids and others. I think last week we've been talking about AI, and it looks like we have a big overrun of questions about AI here. So, I've got something I was thinking about, which is sort of what's going to happen to education in the world of AIs, because it's increasingly the case that the AIs, just as AIs will be able to do things for us, AIs will get to know us better, and they'll get to be better at knowing what to explain to us so that we understand things. That's one thing. The other thing is, in most settings right now, people are in classrooms where there's one teacher and there's a whole bunch of students. When one's able to interact with a good AI, the AI will be able to give one sort of personalized instruction. It's kind of like being a one-on-one student and teacher. And that will accelerate the rate at which people can learn things. As the AIs learn more about us humans and how we learn and how a specific human learns, the AI is going to be better at saying, this is the one thing I need to tell you right now. This is what you're confused about. Let me explain that one particular thing to you. And so I think what's going to happen is that the speed at which we humans can learn things is going to increase. I don't know how much, 5 times maybe, I'm not sure. The other thing that will probably happen is you know something and it kind of gradually decays and you kind of forget the details. And then it probably will be the case that sort of the refresher is also AI-able, and it'll be the case that you can, when you start saying, well, I need to remember about this, and the AI can ask you a couple of questions, and then it realizes you've forgotten that part, and it's going to feed you back that part, and then that helps jog your memory, however that works. We don't know how that works for humans exactly. Maybe we'll learn a bit how it works from looking at AIs. Actually, that's one thing to point out. It's interesting about ChatGPT and the large language models, LLMs, and so on, is that the types of mistakes they make and the types of things they can do are very human. And it's something where we haven't really had a theory of why do people sort of not manage to solve that math problem quite correctly? How do these people get a little bit confused about this or that? Probably by studying LLMs, we'll be able to get an idea of how those human mistakes are getting made. And potentially, what you tell the human, at what moment you should tell the human to do something in order to avoid the mistake. There are many fields in which people have gradually learnt how to get humans to not make mistakes. For example, there are plenty of fields in which there's checklists are an important thing. Kind of like, did you remember those 10 things you're supposed to do before you fly the airplane off? Well, actually, it's more than 10 for airplanes, but and this idea of let's have a checklist and you specifically go through this, checking it off. That's kind of a mechanism for preventing one making mistakes. I know in my efforts at programming, I've done a lot of programming in my life. And one of the things I learned early on was the types of mistakes that I make. And so gradually I got to be, well, I know what type of mistake I make. So let me be careful when I've written this piece of code, let me be careful to check it for that type of mistake. I'll say another thing. When I write text, my absolutely most common mistake is leaving words out. And I think that but so given that I know that, when I'm reading through what I've written and so on, I'm alert for the fact that, it might have a word missed out, including, the word not and things like this. So I think that's the kind of thing where, as we kind of, learning the types of mistakes we make is something that is a very doable thing for AIs. And being able to see this particular LLM makes this particular kind of mistake. I don't think any of the LLMs will make the leaving words out mistake, of the current ones at least. I'm kind of wondering if you overclock it so that you're insisting that it produces tokens at a very rapid rate, maybe you can get it to leave words out. And maybe that's my brain's problem, so to speak, when I write text and leave words out. I'm not sure. So in any case, let's see. There are a bunch of questions here. My gosh, lots and lots of things. Okay, lots of interesting questions. There's a question here about the future of jobs. When we're able to provide basic things to everyone with a machine, like food, water, shelter, and so on, at that point, will jobs be obsolete or not? This is a long-running story of history. It's when is enough enough? That is, there comes a time when, in some developed country or whatever else, in at least some part of the country, it's like getting the food you need to eat is not a big problem, or getting, shelter is not a big problem. At earlier times or in different places, maybe that is still a problem, but for some large class of people, it's not a problem. And then the question is, well, then you just sit back and do nothing then? Well, it's not the way our species seems to be built, for better or worse. It's like people always want to do more. If you can get the basics taken care of, for many people at least, it's kind of like there's more stuff that one wants to do, or that in a sense needs to be done. I mean, it's kind of like, a good example is houses. If you say, what was a house like 300 years ago? Okay, it had walls, it had maybe some windows, it had, it had rooms, et cetera, et cetera, et cetera. But now if you look at a house, what's in its walls? It's got all kinds of stuff. It's got all the electrical wiring, it's got plumbing, it's got network cables, it's got all kinds of stuff. And the expectations for what a house should consist of have considerably increased. And which is why, for example, construction, even though many things can be pre-manufactured, many things are more automatic, have more machines and so on, still takes a significant amount of time. And I think that's the thing that happens all over the place, is expectations go up. It's not enough just to have sort of basic food to eat. If you're going to eat, I don't know, some, bread and something or other every day, that's not enough. You have to have something more than that. And that tends to be the thing that I think is a driver for, the idea that you don't get, even if you can automate to some level, that automation then provides you the possibility of doing more things, and then there's more things for people to do. And I think what can also happen is, once something has been automated, then sort of more of it happens, and that can generate issues that necessarily require people to deal with them, at least until one has understood those things well enough that one can then automate to the next level. So I think it won't be the case that jobs will be obsolete. I think one thing that you do see in economies, and you see it even in today's world, but you see it also historically, is as economies get more developed, the number of different kinds of jobs that get done dramatically increases. Like in the US 150 years ago, the majority of jobs were agricultural, farming. But nowadays, the pie chart of what jobs people do is pretty finely sliced into all kinds of different categories. And I think that's a thing that one will tend to see. As more is automated, more different things, there are more different things that people can do and choose to do and so on. And so I also suspect, and this is a different point about sort of what jobs people do, and do they only do one job, or do they do multiple kinds of things? I suspect there will be more and more of people are not just doing this, they're also doing that. I mean, for myself, I have for a long time, run a tech company for 36 years now. I also try and do basic science. I also try and do some educational kinds of things. I also do stuff about history and so on. I'm a sort of, in a sense, I have, I've chosen to have the equivalent of multiple careers, so to speak, all mushed together, and they have many interactions between them, but they're really different kinds of activities. And I think that will be something, I know many people who are likewise, and I think that's a thing that will be increasingly common. It always used to be the case. People would have, they would have their work, they would have their hobby. I think there's going to be more of a, hobbies become work, and work becomes, if one's lucky, one's doing work that one enjoys as much as one would a hobby, so to speak. But I think when it comes, we can see in the world today, people who were like, oh, I play video games for fun. Well, actually, I'm making a living as a, esports, or a live streamer of playing video games and so on. So a lot of these things that were just hobby become less less hobbyist, and become sort of secondary jobs, so to speak. So I think the landscape of what people do will, my guess is that one of the things is they'll be more fragmented. There are more different categories. There are more different, an individual person might do more different kinds of things that they might say, where any one of them could have been a whole job before, but now it's just part of part of the portfolio of things people do. Let's see. Dr. Verm here is asking, are we about to reach a post-truth world due to AI-enabled misinformation? How do we combat this? It's always a complicated thing, because it is, it was the case that writing something, publishing it in a newspaper and so on, it's all a lot of effort. The newspaper, you're printing something in a newspaper. Okay. I've even seen these giant printing presses for newspapers, and they're, it's a big production. It's like it costs a lot of money. You switch on the presses, the big streams of paper go through, and you're printing things for newspapers, and then you're delivering the newspapers to places and so on. It's all a lot of effort, and it has to be worth something to go to all that effort. It's if you write some completely uninteresting, nonsense story that nobody cares about, you're not going to go to the trouble of printing it, distributing the newspapers, doing all those kinds of things. But when one's dealing with the web and so on, the cost of putting some content out there has gone down to basically nothing. And so what was kind of this big constraint that, nobody bothers to publish a book, a newspaper, whatever else, that nobody's going to read, or that's complete nonsense or whatever, maybe sometimes it'll be nonsense, but highly entertaining, and lots of people will read it. That's a different dynamic. But the idea that there's kind of a, the sort of a threshold that had to be passed for information to get out there, that threshold is now zero. There has been at least some threshold, which is somebody's got to actually write that whole essay about, how how a llama escaped from the local zoo and started, eating its way through whatever. Somebody's got to write that piece. Well, except now they don't, because with large language models and so on, it's rather easy to say, write a story about how a llama escaped from a zoo. Write a story about how a llama escaped from this particular zoo. Feed it a few facts about the zoo, and you've got a completely realistic story about a llama escaping from a zoo and hopping over fences and whatever llamas do. And then the problem is that the cost of producing that is exceptionally low. You put it out on the web where the cost of distribution is exceptionally low, and you've got a story that may have absolutely nothing to do with anything. Now, you say, well, that story about the llama, it's misinformation. There wasn't any llama. It didn't do that. There was no llama that that kind of did jumped in the air and did a backflip type thing, or whatever it is. But yet it was written as a beautiful essay, and it was put out on the web, and it's like, this is all, nonsense. Well, of course, you have to realize that there's fiction is a perfectly valid form of human expression, and you could have a lovely story about the llama that did this and learned to be a gymnastic llama or whatever else. That's a valid thing. Now you might say, identify this is a work of fiction. I was just using ChatGPT yesterday, asking it to writes something, and it now makes a big effort to say, of course, this isn't real. This is a work of fiction and satire, and then it goes and writes the thing. So it's beginning to try to have some awareness of that type of issue. But that's one thing to say. Another thing to say is when one even defines, what's misinformation, what's true, what's not true, etc. It's often very hard to know. There are some domains, like, well, take mathematics, for example. You think you know what's true, what's not true. 2 + 2 = 4, 2 + 2 doesn't equal 5, okay? But there is does 2 + 1 = 3, or does 2 + 1 = 0 or 1? Well, you say, how could 2 + 1 = 1? Well, if you happen to be working in mod 2 arithmetic, kind of clock arithmetic, where 2 is equivalent to 0, then 2 + 1 = 1. But you say, but that's not what I meant by plus, and so on. Well, it gets a little bit more complicated, even in an area like mathematics, and it's a much deeper issue in mathematics, that there can be questions that, given any fixed set of sort of axioms that define mathematics, you can end up with questions where you can't decide whether they're true or not based on those axioms. So even an area as firmly kind of tied down as mathematics, the question of what's true is actually a bit complicated. And when it comes to things about the world, it's vastly complicated. For example, I don't know. Well, here's a good one. The llama likes to eat peanuts. Okay, really? I mean, you have a llama. You hand it some peanuts. The llama grabs the peanuts and eats them. Then it makes a funny face, and indicating that it really didn't like the taste of those. Okay, did the llama like eating the peanuts? Did it not like eating the peanuts? Another llama might, look at the peanuts and brush them aside, or whatever it is. The question of does the llama like eating peanuts is a complicated one. And obviously you can have versions of that when it comes to, people and opinions about people. Oh, so-and-so, is a terrible person in this way. Oh, so-and-so, but actually in this way, they're not a terrible person, so on. It gets very complicated to know. And usually human language is a very inexact way to kind of state what's true and what's not, so to speak. One of the only places where we really have pretty tied down notion of something analogous to truth is in computational language. If you write a piece of Wolfram language code and it says this, then you run it and it does the thing it is defined to do when it is run. The function plus in Wolfram language does a particular thing. It's not kind of an everyday language plus where it could mean this, it could mean that, and so on. So I think this question of kind of what, as I say, in the case of there's certain kinds of things which get very sort of computational, where you can actually tie down the notion of does this equal that, and so on. But when it comes to human language, and when it comes to even things like mathematics, the question of sort of what's ultimately true is a pretty complicated question. And so, there are cases in which somebody, and this whole issue of what is intended to be fact, what is intended to be fiction, what is intended to be, and one of the things that's been tricky, and I must say I'm not a big fan of, is the idea, and it's something, during the pandemic, for example, it's something that was often discussed, governments, for example, or other organizations telling people, emphasizing this thing, it's really dangerous to do this, or it's really whatever to do that. And you could say it's really dangerous to do X. Well, what does that actually mean? There's some probability that you'll get this thing that will happen based on 1,000 samples and this and that and the other. But sometimes there was kind of an idea that you tell people it's really dangerous, then they won't do it, and that's good in general for some reason. And this idea that what you say, the words you use to describe things, can be, you'll use it's really dangerous. as opposed to there's a probability of 1 in 7 that you will get, you'll get sicker or something if you do this. Saying it's really dangerous to do it versus there's a probability of 1 in 7 that this will happen is a matter of, they might both mean the same thing. To some people, it's really dangerous to do this means there's a 1 in 7 chance that you'll get really sick. Would be, that's a perfect translation between those things. But to other people, it's really dangerous they'll hear that as something very different from there's a probability of 1 in 7 to do this or that thing. And I think there's a certain, it's complicated to say, is it misinformation to say it's really dangerous to do this when the probability is 1 in 7? Some people might say, oh, well, it depends on, what the end point is, how sick you're going to get. And even if it's 1 in 50 and you get really sick, you might still say it's really dangerous to do X. If the chance is 1 in 50 million, but there's a chance that, something terrible happens to you if you do it, most people probably would not say it's valid sort of to say it's really dangerous to do X. But so I think it's really difficult to have a definition of misinformation, so to speak. And I think one of the things that's sort of interesting is that in today's world with LLMs and so on, this question of sort of making these judgment calls about whether it's a good idea, whether something is okay or not, it's kind of going to be an interesting LLM meets LLM story. Because, for example, if you host a website and you say, I don't want any pictures on this website that depict anything bad happening to animals, let's say. Well, you can, and that's your terms of service, so to speak. Question is, how do you decide that? Well, you could have some team of people and they look at all these pictures and they say, this cat doesn't look very happy in this picture, whatever else it is. Or you could have an AI system that basically where you give it a textual prompt that says, that all animals depicted in all these pictures have to look happy, or whatever it is. And it will, based on the training that it's had, based on the average of having seen lots of pictures on the web and descriptions of those pictures, which said, happy cat, whatever it said, unhappy cat, whatever else it was, based on all of that kind of training data, then the AI will be able to give some conclusion about, is this picture that you're feeding in that you want to put on this website, is it okay or not? And I think that's something we're going to increasingly see is kind of these judgment calls, particularly when it comes to, is this an okay thing to post on the social network? Is it not? Those judgment calls will be made by LLM AI-like systems. And, I think that's it's a funny situation because you might say, if it was the case that the decision was made just based on the words that were used, if you were never able to use the word bad, okay, then people will find ways. If it's a very coarse criterion like that, no post will ever let you have the word bad in it. Okay, then people will say, they'll say, backwards dab or something. They'll find a way just to run around it so that the people who are reading it can perfectly well understand what they meant before. But what's tricky with something like an LLM is that you're kind of up against a kind of computational barrier because people don't know yet. Maybe we'll discover a little bit how to do this, how to game an LLM. I mean, people don't know. It's kind of related to the sort of emerging field of prompt engineering of, what do you tell an LLM? For example, we've had this issue. We now have this Wolfram plugin for ChatGPT, and we need to be able to tell it, send this kind of input to this piece of our plugin, send that kind of input to that piece of our plugin, clean up the input that you're going to feed to our plugin in this or that way. And we try putting capital letters, we try putting stars around things in the textual prompt, and the LLM sometimes pays attention and sometimes doesn't. And in our particular case, we solve that technologically by having sort of a catcher for what the LLM sends that tries to clean up the mistakes that it makes. But there's the question of, well, is there a science of really getting the LLM to do what you want? I mean, it kind of reminds me of if you are managing people and you really want the people to do what you want, what do you tell them? I don't think I know the answer to that, even though I've been doing management for, 40 years or something, more than 40 years now. I don't think I could tell you the ultimate, this is the exact thing you tell people to get them to do exactly what you want them to do, so to speak. It's sort of still an art form, and whether there'll be some kind of, yes, you can just lock the LLM in to do this, I'm not sure. But I think the idea of this kind of rather than saying, oh, there are these bad words, don't use those bad words, and it's a very sort of coarse way where you can always sort of walk around the bad word type thing. If it's kind of, you're doing this thing and it's being graded, it's being rated by, it's being decided by an LLM, I think it's not going to be so easy to game, and it will do something which seems to be a fairly human job. And sometimes one will say, just as one does with humans, oh, that person goofed, they should have agreed that this was okay, or they, why did they say it wasn't okay? They made a mistake, et cetera, et cetera, et cetera. And you'll say that about the LLMs as well. But I think it will be, that will be a common thing. So then you could apply that to sort of the misinformation story. You could ask an LLM, you could say, on this site, we won't allow any misinformation. Okay, what does that mean? Well, the LLM can go and try and decide, is this misinformation? It's looked at the web, it's got a lot of things which are tagged as this is misinformation. So it probably has some idea what misinformation, what people think of as misinformation. And so, it will have a fighting chance of doing something reasonable there. Of course, it won't always catch it, and but I think that's a thing one will see. Now, the thing that I'm is absolutely a thing one will see is just tons of material put out there on the web, where and elsewhere, where it was written by an LLM. It may or may not have anything to do with anything. It was just, the LLM was just told, write something that goes along these lines. And now it's easier to do that writing. So I think that's kind of, was it written by an LLM? Was it not written by an LLM? At this point, us humans have some sense of, this is what ChatGPT typically writes. But it doesn't need to be that way. And I'm quite certain that there will be LLMs that will kind of evade any kind of, was it an LLM or was it a human type question. I think one shouldn't count on the fact that unless the AI chooses to declare itself as I am an AI, or unless it's really burnt deep into the sort of psyches of the AI, that I'm always going to explain that I'm an AI, I don't think one will be able to tell. And this is a thing, back in 1950, when Alan Turing, one of the sort of pioneers of computing, invented this Turing test, which was this kind of a notion of, when do we know we have true artificial intelligence? Well, you have a, well, I think he had a teletype, I think was what he was using, but we could modernize that. You're just typing to something, and you're typing text messages to something. Can you tell if the thing at the other end of your text messaging stream is a human or an AI? And his sort of test for, well, we'll know we have genuine AI is when you can't tell. And I'm sure we've got to that point now in the last few months. So anyway, Haraz asks, since today ChatGPT can only reproduce written human reasoning, will it ever be possible for ChatGPT to be better than humans one day? I think the answer is yes. There will be things that it will do better than humans. I mean, the thing that I think it's pretty good at is implicitly noticing patterns across large amounts of information. So it's pretty good at making analogies. Hand is to finger as foot is to toe, or whatever, but much grander analogies. And some of the things that one's interested in science and other places are, I know that pattern. I've seen something like this before. This thing that I'm trying to solve in physics is just like this thing that I solved before in chemistry, let's say. And for a human, that can be something of a stretch to notice that analogy. You have to understand something about both of those fields. For the AI, it's got it's ingested knowledge about, it's ingested at least text about those different fields, and it's going to notice, gosh, there's this analogy here between economics and I don't know, some area of mathematics or something, or physics, let's say. And because very few humans knew both of those fields, they were not able to make such an analogy. I mean, I have to say, this is one of these things where I feel a little bit, there's things I have to figure out in science quickly, because otherwise I don't get to figure them out. It'll just be an AI that figures them out. Because for somebody like me, I'm interested in a lot of different fields and have learned a fair amount about a lot of different fields. And so I've been lucky enough to be able to make some of those sort of grand analogies between very different fields that people are not easily able to make usually, because they just don't know, the two ends of that analogy. I think AIs will routinely be able to make some of those things, and they'll seem very sort of superhumanly smart. But I think it's more because they are broader than because they are deeper. And I think that's something we will probably see. I think that in terms of the access that AIs have to deep computation, I mean, an LLM is really just, even though it's very useful and impressive, what it's doing is it's sort of taking some stream of words and it's saying, how would I continue the stream of words based on what's typical about what's found in the web and on books and things like that. And that process of how would I typically continue it can seem very sophisticated to us. It involves lots of reasoning because, well, the reason it seems like it involves reasoning is the same reason that was how sort of logic was deduced from text. It's like there are these patterns of, if the text says this, then it's going to say this. And those patterns you see over and over again. If it says this, then it's going to say this. That is the structure of certain kinds of reasoning. And it's able to kind of lift that structure from one place to another. That's kind of the nature of the way that it does generalization. And so that means it can apply quotes reasoning because it's seen this pattern of this implies that in lots and lots of different cases. So it's going to lift that and apply it in some other place. I think the thing that is really interesting is the sort of deep computation, the kind of computation that was discovered in the last 50 years, which, that I've spent lots of effort on, of being able to really compute things about the world, where you're running lots of computation steps to figure out things about the world, to work out things about nature, to work out things about the mathematical world, and so on. That's not the kind of thing that a large language model can do. It's a much shallower kind of computation that's just sort of trying to match up what it's otherwise seen as text on the web and so on. And so the merger of those two things, being able to take that kind of thing that is a good match for us humans with human language and so on, and being able to connect it to kind of the depth of computation that in the last 50 years we've realized is possible, that's really powerful. And that's the thing that this plugin for ChatGPT that we built, connecting to our kind of computational system, that's what that enables. And I think the thing that's going to happen, which is pretty interesting, is, a thing that I've done for decades now, is the idea of computation and making it accessible to as many people as possible. That's sort of the thing I've been trying to do. And I've done that by creating this kind of computational language that expresses things that we think about in computational terms. Done that in Wolfram Alpha, for example, where you can type a small piece of natural language and just get a computational result out. But we've now got a much broader version of that. With LLMs, we can take a much more sophisticated set of instructions, so to speak, and expect to turn that into our Wolfram language computational language. And that's really powerful, because then, just from thinking about things in terms of natural language, you're creating this computational language that then lets a computer go off and really, run what a computer can run, so to speak, and figure out and make use of what's possible in the computational universe, so to speak, to figure out a lot of things, and then can bring it back and can express it in natural language and so on. So we finally got the ability, in the past, we've had sort of, there's the programmer thing, there's the computing thing, and then there's the talking about things in natural language. Those two things are finally merging, and that gives just sort of everybody access to much deeper computation, something we achieved a dozen years ago with Wolfram Alpha for certain kinds of knowledge and certain kinds of quick questions where you're just saying, I want to know the answer to this question. Wolfram Alpha can do that. If you want to say, I want to create a program that's going to run 1,000 times to do this particular thing for this thing, that's not what Wolfram Alpha is set up to do. But now with LLMs plus the technology we have for connecting it to Wolfram language, you can do that. And that's really something I think exciting, because it kind of opens up the sort of power of computation, the power of this kind of knowledge-based computation that we have in Wolfram language and so on, to everybody. And it's, people have been worried that, oh, they're the people who learn, techie stuff and programming and so on, and the people who don't. But there's a lot of power that comes from the notion of computation, and that's sort of always, that has in the past been kind of separated off from people who didn't learn sort of how to talk to their computers. But now we've gotten much closer to where you don't really have to learn that. Just like in Wolfram Alpha, there's no documentation for Wolfram Alpha. You just type what you want to type, and it will answer questions. Well, now you're at the point where you can just type what you want to type, and you can make a piece of computational language code that you can then put together in building blocks to build up some sophisticated, to achieve what you want to achieve computationally. I will say there's one kind of footnote to that, which is you kind of got to know when you build up a big tower of computational capabilities, you've kind of got to know that all the bricks you put down in the tower are actually kind of correctly shaped bricks. You didn't start putting foundations down and wind up with the Leaning Tower of Pisa because your first few bricks were misshapen, so to speak, relative to what you thought they were. And so I think that's a place where our computational language is really important, because it is a language that is intended for humans to read. It's not like sort of typical programming languages, which are intended just for a computer to read. It's a language intended for humans to read. And so what you can expect to do now is you tell your LLM something in natural language, it writes Wolfram language code, you read that code potentially, you might just see whether it does the obviously right thing, but if you're at all uncertain about it or you can't quite tell what it does, you read the code. And that's something, well, there's some learning in how you read that code. It's not so difficult to learn that. And then you say, yes, it's doing the right thing. And then you start building this giant tower and it doesn't lean, so to speak. So let's see. Okay, RATC asks, how can AI, through the lens of this concept of computational irreducibility that I talk about a lot, navigate the landscape of possible rule sets and achieve true intelligence mirroring the complexity of our universe? It's a very interesting question. And I think the answer is it can't. What an LLM does is it works a bit like the way our brains work with neural nets and so on. And it does things that are very similar to what we humans do. We humans are not able to go out into the physical world and immediately say, this is how everything in physics is going to work. We're not set up that way. We're set up so that we can answer questions quickly about things that are common in our world. We've kind of evolved through biological evolution, et cetera, et cetera, et cetera. And we've also chosen to set our world up to be one where the kinds of things that we're able to do with our brains, with the neural nets in our brains and so on, the kinds of things that we're able to do are ones that that we've set up our world to be the things that we need to be able to do. We could have set things up so that we're continually confronted with incredible complexity and randomness and so on, but we don't. We choose, I mean, like for example, we choose to make our roads be things where you just drive the car down the road. We could have set up roads to be these complicated things where, you had cars with legs and you had to walk on this, on this, I don't know, I'm thinking of lily pads for a frog or something, but, where you have to walk on this paving stone, that stone and so on. And it's very difficult to get from one place to another. You have to carefully choose where you put your legs. but we don't. We set up our world to have roads where you just drive straight down there in your car or whatever else it is. And so it's something where we've chosen to build our world so that we can navigate it with the apparatus that we have in our brains. And we also, we choose to not consider those parts of the physical world. We don't live in places, so to speak, where it's very hard to navigate what's going on. We don't, so there are things that we can do, and we set up our world to be a place where we can, do the things we can do, so to speak. If you say, well, what's out there in principle? Well, what's out there in principle is a lot of incredible complexity, lots of computational processes that are irreducible in the sense that you can't predict what they're going to do. But those are things that we as humans tend to avoid. And our AIs, sort of modeled on us, will have the same issues with those kinds of things. You won't, what you might be able to do is to say, for an AI, you say, here's this computational system, it's really complicated, etc. And the AI will kind of channel us humans, and it'll say, well, I think a human would say this or that about it. In the abstract, it's not going to have something vastly beyond what humans can say. Now, it's a little bit of a few sort of footnotes to that comment. So, if you look at the course of human intellectual history, we've gradually learned how to talk about more and more kinds of things. We've learned new ideas, new concepts, and so on. That gradually allows us to expand the domain of computational things that we can talk about. But one thing to realize is, if we expand to some new domain, we can now talk about, let's say, fractal patterns. Well, the fact that I can talk about them is because I got a word, fractal patterns. We have some sort of common understanding of what that word might mean. If you just go out as a solo person and you say, and I've done this, I have to say, you go out into the sort of computational universe of possible programs, you find all these programs, you have a little idea in your mind of how these programs work, but you don't have a way to describe it. You don't have sort of a narrative you can tell about it. It's kind of a funny situation, because you don't really have, that's not a place where you can sort of talk about what you've seen, because you have no words to describe it. You have no way to communicate what you've seen. So what I think tends to happen is we humans, sort of as a collective society or something, we gradually move further out in the domain that we can understand, and we sort of build up a language, a narrative for how we describe those things, and we could tell it to other humans, and we're all sort of together moving outwards in this domain of things we can understand. Now, in AI, it could do that too, and it could be like happily telling its other AIs what's going on. But unless it can teach that to us humans, unless it gets a bunch of humans involved as well, then it's in a sense, it's just going out, and it's a little bit like that computational system that it's studying. It's just something, it's doing some complicated computation. We as humans can't tell what it's doing. It hasn't successfully kind of expanded its domain in a way that we humans are connected to and care about. So I think that's sort of the issue, is that it has to not only kind of be able to be looking at things that are sort of further out in this domain of computation, it also has to have invented for us and taught us a language for how to talk about those things. And it's perhaps an interesting thing to try to explicitly do that, and to have the AI sort of come up with a language. And then it's a question of, okay, I've got to, sit still long enough to actually learn that language, so I can kind of ingest that, get it into my mind, so that I can, so it becomes something meaningful to me, as opposed to something, well, yes, the AI is doing it, and it's a lot of bits inside the computer that are flapping around in this or that way, but it doesn't really mean anything to me. It doesn't really connect with me. SVD asks, will we see more of the phenomenon where AI contributes to the fundamentals of science? We haven't so much seen that yet. I mean, there have been sort of AI-like techniques for quite a long time. One of them is automated theorem proving, being able to take a mathematical theorem and use the axioms of mathematics to try and figure out, can you use those axioms to construct the sort of path that represents a proof of the theorem. I believe that the only time that an unexpected discovery has been made by automated theorem proving was something I discovered 23 years ago now about the minimum axiom system for Boolean algebra. Most of the time, that technique of automated theorem proving has only really been used to confirm things that people already thought were true. It's actually surprisingly rare that sort of, I mean, and again, I myself have done a bunch of work along these lines of using what amounts to AI to discover unexpected things in science. Now, one of the things to say about that, and it relates to what I was just saying before, is that if you just see, okay, you've got this weird phenomenon, you can generate it on a computer, you don't have a way to talk about that phenomenon. It's just this weird phenomenon. You've never seen it before. It's just a weird phenomenon. And until you have a conceptual framework, until you have a way to talk about that, to kind of put it in a framework where it fits in with other things, you won't tend to think of that as being progress in science. You'll just say, this is this weird random phenomenon that isn't really connected to anything else. The progress of science tends to be making this sort of broad connection where you can have a narrative that lots of people understand, that you can sort of, you know, pull into your mind, so to speak, that represents that piece of progress. So I think that's one thing to say. Another thing to say is when it comes to LLMs themselves, there is science to be done about how they work. There's a lot of questions about things that are empirically observed, and why is that true? Things about how big the LLM has to be compared to how much it's learning, et cetera, et cetera, et cetera. That's something I've been encouraging some scientists, physicists particularly recently to study this, because I think that it probably is figurable out why these kinds of principles exist. But that isn't known. And I think there's a lot of kind of science to be worked out about kind of why the how the LLM successfully puts together the language in the way that it puts it together. There's facts about language. People have tried to make a sort of science of how language works. Linguistics is sort of a science of how language works. They haven't been terribly successful. A few things can be said, a few, you know, most languages seem to have nouns and verbs and adjectives and things. Those are categories that seem to be fairly robust across different languages. There are aspects of the way that you make sort of subclauses in sentences and so on that seem to be fairly universal. But I would say as a whole, I would argue that sort of the science of linguistics, of saying why are languages the way they are for us humans, and what sort of global features are there in those languages, hasn't been particularly successful. I think the success of the LLMs is showing us there is a way to do that stuff. We just didn't do it quite right yet. And that's a place where I think the AIs will contribute by the very nature of them working to an understanding, to a better understanding for us of a phenomenon like human language and so on. Let's see. Satoshi is asking, what do I think about AI alignment and the existential risk of AI? Well, okay, let me explain what that means. First of all, you've got an AI, it's doing what it does. The question is what it's generally doing aligned with what we humans want it to do? Like, for example, you've got an AI and it's supposedly, you know, picking content for some internet site. And we say, is it doing that in a way that, and it's figured out that, you know, it puts this kind of content on and more people will click on it and things like this. Is it doing it in a way that is aligned with our overall objectives as a civilization or whatever? You know, how does that work? Well, the first question is, well, what are our overall objectives as a civilization? You know, for example, one objective that we probably mostly agree on is we don't want to go extinct. And so, you know, aligning AIs so AIs don't make us go extinct is probably something we'd all agree about, probably. What it takes to get there, the more minor steps, that's quite challenging. And, you know, you can ask, well, what do you want to generally say that AIs should do? Let me give you an example. A thing you might very well say is, I want AIs, let's say an AI is owned by somebody. It's on a computer, the computer is owned by somebody, the software is owned by somebody, and so on. You might say, I want that AI to do whatever its owner tells it to do, make it do it. Seems like a reasonable thing. You say, but wait a minute, if the owner tells it to, do some terrible thing in the world, surely you want the AI to say, no, 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 I'm not going to do that. It's just like if you have, a self-driving car or a car with a bunch of automation, and you say, I want to go faster, 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 and the car knows it's a 30-mile-an-hour speed limit zone. Does it go to 35 miles an hour or 40 miles an hour or whatever? Or does it say, no, 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 not going to do that. It's a 30-mile-an-hour speed limit. I'm just going to stay to that. Complicated question. There are cases in which you'd say, well, gosh, if you couldn't do that extra 2 miles an hour, you'd have an accident. And that will be a worse outcome than, oh, you went slightly above the speed limit. So, and it's hard to decide whether you, for example, the question of should an AI do what its owner tells it to do? You might very well say, well, for societal reasons, you want to pull back from that, maybe, or you want to say, maybe you want to have as a sort of primary objective that it's always humans in charge, in which case, yeah, you should make the AI do whatever its human owner tells it to do. Of course, it gets more ornate when you have an AI toy for a cat, and you say, does it always do what the cat tells it to do? Well, then you're in another whole complicated loop of, but the question of sort of what are the provisions? What are the kind of elements of what one can think of as sort of an AI constitution? What do you put in there to say you want the AI to do this, you don't want the AI to do that? One of the things that's very bizarre in today's world is that, and today's, I mean, last few months, is that you give these textual prompts that say what you want the AI to do. And you're literally writing something that looks very much like a piece of legal document that says, do this, don't do this, et cetera, et cetera, et cetera. And I think that's something I was not anticipating. I think to some extent, at some level, people will find that a bit unsatisfactory because they'll say, what does it really mean? Well, of course, they've said that about the US Constitution or laws or whatever else forever. What is the interpretation of these words? Well, that's where people, when they can turn them into computational language, where there is a well-defined meaning that is defined by what the thing does when it runs as a computation, there will be a desire to do that, I think, in a bunch of cases. But this whole question about, how do you get the AIs to, quotes, do what we want? Depends what it means to do what we want. It depends how globally you have to have people agree about what things, whether all the AIs need to be pointed in the same direction. It's the thing, I think I mentioned this another time, about, does everybody drive on the same side of the road? You can't have, at least in a simple way of setting things up, you can't have some people driving on one side of the road, some people driving on the other side of the road, because then the cars crash into each other. Of course, if the cars were smart enough and were self-driving enough, they'd be able to dodge each other, and you could have a much less sort of rigorously defined, it's the left drivers and the right drivers type thing. I think that you don't then have to have as much, in that particular case, sort of AI itself saves you from having to have as much sort of global alignment between what the different AIs are doing in that case. But there are certainly cases where, we share the space and other resources of the world, so to speak. And there are places where, you can't have one thing, I don't know what they might do, generating a huge noise, and then somebody right next door is like trying to sleep or whatever else. That's going to lead to unhappiness, just because you could say, well, you can sort of solve it with technology. Let's have this phased array that's sort of a noise canceling array that the thing can put up, so that there's noise in one place and it only affects those one set of people, and one house over, it's perfectly quiet because of this complicated cancellation of sound waves and things, or something like that. But there are plenty of cases where there's sort of a collective experience where you have to have sort of an alignment there, and that's a tricky thing to achieve. I mean, I think one of the things I was thinking about is, let's say you've got lots of people, they have lots of opinions about things, And you say, well, what's going to happen in the world? What should you do in the world? Well, an interesting sort of possibility is everybody writes an essay. Everybody writes what amounts to a prompt for an LLM. And you just feed them all into the LLM. You say, here's 10,000 prompts that came from all the people who live in this particular part of the city or something. And okay, LLM, should we build a park here or not? And the LLM is just has ingested all of these essays by people, some people saying, I really want to fly a kite. Some people saying, I really want to have a road that gets faster from here to there, all those kinds of things. And it will be interesting to know, is that a sort of post-democracy form of government to say, just everybody write an essay, so to speak, rather than people saying, I vote for so-and-so to be representing me or whatever else. I don't know. I think it's an interesting sort of thought experiment and possibility. It's something that, but as we start talking about the question of whether the AIs are going to do what we want, it's who's the we and how do we decide what we want, so to speak. And that's a tricky thing. Now, as I say, the one thing we probably mostly agree on is AIs don't make us go extinct. I think that's a tricky thing to, I would say that I tend to think we're pretty far away from a situation where the AIs could have any chance of making us go extinct. But it will be the case that AIs will be increasingly hooked up to critical systems in the world. But I think it's probably the case that the kind of, let's make the whole species go extinct in one fell swoop is not really a thing. It's very hard to do. It turns out we're kind of, there's lots of us and 8 billion of us or whatever, and spread over a reasonable sized planet. And it's kind of like there are very few things that are kind of like globally, oh yeah, you press one wrong button and the whole thing blows up type thing. I suppose the closest we have is, one can imagine some terrible situation where somebody makes a designer virus that's just really that's terribly bad for all of us, kills all of us. I think that's actually, it's surprisingly hard to do because usually the more aggressive a virus is, a virus works by, spreads from person to person, mostly. By the time it's a really, really deadly virus, the person will not be out and about infecting other people if the virus has put them totally out of action. That's not always the case. There can be nasty things where there's sort of a delayed time type thing where you get sick, you don't know you're sick, you infect a bunch of other people, and then the virus kind of blows up on you. But, so things like that could happen. And I'm afraid, I tend to think that the nature of, again, for all sorts of reasons about immunology, which let's not go into here, I think that's, again, a very unlikely thing to be like, wipe the whole species out. So I think in terms of, I don't think we're at heavy risk of extinction, so to speak. And the things below that, most of the things below that, it is the case people will not agree about, well, we should make it do this, not that. We should make it, and then it becomes as messy as things in the world typically are. Some AIs will do this, some AIs will do that. It'll be kind of like the way it is with people. Let's see, there's some very interesting questions here. What's it like to be an LLM, asks Brady. Well, I don't know. What's it like to be a computer? I was thinking about that. And even a traditional computer, forget all the AI stuff. It's like you boot the computer up, you start it up, it sort of comes to life, it's interacting with the world, it has a camera, it's watching stuff, it's waiting for people to type on its keyboard, it's building up a certain amount of information in its memory, a certain amount of state for the computer, and then eventually, after a week, a month, whatever else, the computer crashes. The operating system crashes of the computer and it has to restart itself. And that process from startup, from boot up to shutdown is kind of like a human life. It's kind of like you start from a certain genetic template, you start from a certain set of things that are stored on the computer, then you sort of come to life, you record, you remember a bunch of things in your life, and eventually it's the end of your life. And then, you know, your children sort of are you know, carry on or whatever, and they've started from similar genetic material to yours. It's just like kind of the next boot cycle of your computer. It's kind of started from a similar point. And in a sense, the you know, what you know, if you're somebody who writes down your thoughts or records your thoughts or whatever, in a sense, that's what's stored on the disk of the computer. And, you know, for the next generation, when the computer boots up again, that's what will be visible there. And I do think that if we imagine what it's sort of like to be a computer, it's actually surprisingly similar to what it's like to be a human. You know, there's things in the outside world, there's communication with other computers, all those kinds of things. It's surprisingly, you know, you might think, oh, it's just a computer. We can look at it from the outside. Well, you know, humans are just humans. We can look at them from the outside and see what they do. In the case of a computer, we might know a little bit more about how it works inside. I think we're beginning to know more about how brains work inside. We're beginning to know how certainly idealized artificial brains of neural nets work. So I think the experience of being a computer is probably sort of the inner experience of being a computer, if we can imagine that, is like the inner experience, is quite like the inner experience of being human. Of course, we only have our inner experience. I have my inner experience, you all have your inner experiences. I can't know what your inner experience is like. I can kind of see it from the outside. I wish I could see you guys more explicitly here, but you know, I can see from the outside what what your characteristics and behavior are. That doesn't really tell me. It doesn't allow me to get inside and experience you from inside you. I can only experience me from inside me. And so when we look at a computer, we don't get to experience the computer from inside the computer. Maybe one day with neural implants and things like this, we'll get a little bit closer to experiencing the computer from inside the computer, but we're not there yet. Let's see. Question here, there's several very interesting questions here. There's a question here about will programmers become obsolete? Yeah, low-level programming is going to become obsolete in the same way that assembly language programming has become obsolete, became obsolete decades ago now. I mean, you need to tell a computer what to do and tell it what to do in a precise way. The language that I've just spent the last few decades building is the highest level way that we have right now to tell computers what we want them to do precisely. And that's something that's going to continue to be useful. But when it's like, oh, and let's tell the computers in more detail at a lower level what to do, that's automatable. I've known that's automatable for 40 years. I've been in the process of automating it, and I've done a lot to automate it in the last 40 years, and many people have used what we've built. The fact that there are many people writing kind of low-level programs is sort of a strange anomaly of history. I mean, I think perhaps it's an inadequacy on my own part to have not managed to explain to people more clearly, although I think I've done a fair amount along those lines, how you can interact with computers at a higher level. There has been continued interest. No, I should learn to program and write this code and learn about memory allocation and this and that and the other. Those are things which, it's like you drive a car. Yes, it's amusing to know how spark plugs work and how fuel injection works and so on. But most people who drive cars do not need to understand fuel injection. It's a different level, and the same is true of computation, except that people have had the idea that you really do have to understand the fuel injection, as you did. When cars were young, you had to understand all kinds of things about how they worked in order to use a car. But then they got more automated and you don't have to do that. Gosh, there's a question here from Assist. What are suggestions for a high school student who is interested in both AI and physics? Come to our summer program. That's a good, very practical suggestion. I think that it depends what kind of physics, and maybe this is, I know I have to go in a minute, so I'm not going to have a chance to give this question its real best response. I think one of the things that kind of has come out of the physics project we've done in the last 3 years is physics is ultimately computational. We didn't know that before. We thought physics was mathematical, but it isn't. It's computational as well as mathematical. And so the things that come out of understanding the concepts of computation are really important now, very recent knowledge, to understanding physics. And sort of there's an increasing opportunity for people who understand computation to contribute to physics and to contribute to the foundations of physics. And we're seeing that in the few hundred people probably who are working on sort of our approach to physics at this point. It's like you really have to understand the computation side of things. There's some pieces you can do with sort of more mathematical physics as well, but it's very useful to understand the computational aspect of things. And that's a bit like what's true in AI. Now, one issue about AI is there's a lot of kind of engineering plumbing that has been traditionally done in AI. I don't know how much that's going to continue, but that's been, and it makes it much more like an engineering field and much less like a theoretical science field. I think there may emerge a theoretical science kind of field in AI that hasn't really emerged yet. But the thing, it's kind of like there has been in the past, there's engineering on the one side in AI, there's kind of mathematical type science on the other side in physics. Now both of these look more computational. Now in the case of AI, I would say the biggest question these days is, okay, so we've got these capabilities for AIs, how are we going to be able to use those? That's sort of more so than let's go and understand more about the details of the capabilities. It's kind of how do we take this building block and use it to make further progress. There's more to say about this. Maybe I can cover it again next week. But I think I have to wrap up now because I've got to go and do some day job work here. But thanks for joining me, and thanks for these interesting questions. It seems like we're in an AI, in the history of AI, there was sort of this period of the AI winter when it seemed like nothing was going to work in AI. I think we're now in the AI midsummer day or something, where it seems like everything is working with AI, and perhaps we can continue talking about AI, but next week. But thanks very much, and bye for now.